For this demonstration, I'll be going over the new steel girder bridge modeling wizard. Using this wizard, you can create highly detailed and complex steel girder bridge models within a few minutes. So in order to access the wizard, let's select the Structure tab, and then select the steel girder bridge icon. Once the icon is selected, you'll find an input menu with 4 tabs. And the first tab is the Layout tab, where you can define the geometry of the bridge. The second is where you can define the materials, bracing, and girder sections of the bridge. Here is the Section tab. The third tab is the Load tab, where you can define the dead loads and live loads. The fourth and final tab is the Construct tab, in which you can define the construction stages. Now I'll use the wizard to create a detailed, finite element curved steel girder bridge model. If you open the first girder type drop-down menu, you'll see that you can select a composite steel eye, a composite steel box, or a composite steel tub type. So for this model, we'll use a composite steel eye girder. The second girder type drop-down menu allows you to select what element types to use, and most bridge models use only frame elements to make the analysis run faster, so we'll select the all-frame option. Span lengths and deck widths are inputted here, and as well as the skew angle if you're modeling a skewed bridge. If you're modeling a curved bridge, just enter the radius here. And if you're modeling a more complex multi-curve bridge, you can use this input menu to enter the various radii and coordinates to create the curves. So for the boundary section, you can select either a bearing type or a width substructure. And here you can see that the bearing type option, you'll only need to define the support types. With the substructure option, you also need to define the substructure section and material properties. But in these steps, it only takes about a few seconds, so it'll allow you to analyze all the substructure elements of your bridge. So for this bridge, I'm going to define the substructures. For the pier cap, I'll select a predefined section. And you can see here I'm clicking on this icon to review all the section and material properties that I've already defined. And also, we can define new materials or section properties through this input menu. Then for the material type, I'm going to select concrete. And for the pier, I'll select the predefined pier section. So now let's move on to the section tab. So I'll leave the deck thickness at the default value of 0.8 feet, and I'll define the material types for my structural elements. So for concrete, that will be the deck, the steel reinforced concrete for the girder, and steel for the bracing. So here I can define the number of girders, and the default value is 4. But as you can see, I can change it by changing the number and selecting Apply. For the transverse deck elements, I can select to model them by either distance or division, and I can define the angle as well. So now I'm going to define the bracing information. And this is the most valuable feature of the wizard. Since creating the bracings is often one of the most tedious and time-consuming portions of modeling, we use this wizard so you can actually develop or create dozens or even hundreds of bracings in a few simple steps. So, as you can see here, you can select either a traditional frame bracing system or a single beam bracing system. And for this bridge, we're going to go with a frame bracing system. So first, let's define elements as truss types. And then we'll define angle section types for the top and bracing portions of the frame. You can also define the bracing shape as an X brace or V brace or inverted V brace. And we'll use an X brace shape, and then we'll define the angle section for the bottom portion as well. So now let's select Modify to save the changes we've made. Also, keep in mind that you can create multiple bracing types and assign them to different portions of the bridge. But for this bridge, we'll just use this one bracing type. So as you can see in the spreadsheet, the bracing we've defined will be assigned throughout the length of the bridge with a spacing of 10 feet. And in the girder information section, we're going to select how the girder sections will be assigned along the length of the bridge. So since the moment acting on the girders is negative in the center of the spans and positive around the piers, we're going to assign different girder sections to each, and we want to assign the lengths in the spreadsheet. So once the lengths are assigned, we can choose to have the parameters copied to all of the other girders by selecting this icon. And as you can see, all the data has been carried over to the other 3 girders. So you also have the option, as a side note, to generate the 10th point element, which is required by certain DOTs and so forth. So moving on, we'll be going into the Load tab. We can define the spacing and width of the barrier sections here. And using the diagram as a reference, you can easily define all the geometry. Once you've done that, the dead loads will automatically be applied when the model is created. And this is much more efficient because manually defining the dead loads for each barrier can be very cumbersome. So as you can see, you can also have the option of defining all of the weight parameters in the section below. The live loads can be defined in the wizard as well, and we can also go over that later on in this demonstration. So moving on, let's talk about the Construct tab. As you can see, the construction stages have been automatically defined. The substructures, girders, bracings, deck, and the application of composite loading are given their own stages. Here you can also define the durations by changing the numbers in the spreadsheet. And all in all, this is another particularly useful function of the wizard, since you now no longer have to manually define the construction stages, and instead the program automatically takes information you entered in the previous tabs and arranges the construction stages for you. So now the only thing you really need to do is define the duration of each stage, and this function saves a considerable amount of time and effort in modeling, particularly for projects with lengthy construction stage sequences. So moving along, we'll now take a look at the model. Just select OK to generate the model, and as you can see, within just a few seconds, the entire bridge model is created. So first, let's undisplay the nodes so we can take a better look. And here you'll see all the bracings have been generated by the wizard. So for those of you who have had to create bracings for curved bridges before, you know that this process can take multiple hours to do for very large bridge projects. But with this new wizard, you no longer have to create each bracing individually. All you have to do is enter in the bracing information in the wizard, and the modeling will be taken care of you. So the wizard is a sure way to save you a great deal of time. Now, last but not least, we'll look into the construction stages. As you can see here, each individual construction stage has been created by the wizard, and we can view each by scrolling down through this drop-down menu. So, now let's just say you want to create a single stage life model with a live load analysis, and you can undo the model by selecting the Undo option. Then you can reopen the Steel Girder Wizard, and all of your inputs will still be there. So to make a single stage analysis model, you just go to the Construct tab and turn off the Construction Stage option, and now the wizard will only generate the completed model. And then we'll define the moving loads. So we'll go to the Load tab and check on the Live Load option. And first we need to define the moving load code. So as you can see, we all have all of the codes that are used in the industry, including ASHTO LRFD. So we'll select the one that we need. And once we've had that selected, we now need to define the traffic line lanes. So for this model, let's just create one lane with a distance of 7.5 feet from the edge. And as you can see, you can create as many lanes as you need using a diagram as a reference. So the last step is to define the vehicle loads. You can now select the default load standards of the code, and you can specify the dynamic load allowance. So for this model, let's define a truck load with a 33% dynamic load allowance. So now we just click OK, and the wizard generates a single stage model for us. So let's take a look at the traffic line lane. If you right-click here and turn on the display option, we can see how the lane is modeled along the length of the bridge. The last thing we need to do before running the analysis is to define the moving load case. Under the Load tab, just select the moving load case icon, and now we'll define the vehicle class and the lane. So using this input menu, you can easily create multiple moving load combinations from multiple lanes. Okay. So now we're ready to run the analysis. So go to the Analysis tab and select Perform Analysis. The progress of the analysis can be displayed in the message window below. And as you can see here, at a very fast pace, this analysis probably only runs about a few seconds. And there you are. So now let's take a look at some of the results. Select the Results tab and go to the menu on the left to filter through the display options. And once you check on the Deform Shape option, you can actually see an exaggerated image of the expected deformation due to self-weight. So the greater deflection is expected on the outer girders of the bridge because the span lengths are longer. And in addition to the deformations, you can also take a look at the beam diagrams for the girders. Just select the Forces tab, and then we'll select the beam diagrams from the display menu. So now you'll be able to see how the moment changes along the girders as they get closer to the piers. And also you can notice the moment of the girders on the outer portion of the bridge are larger because of the increase in span length. So let's go to the load case drop-down menu to see the moment diagrams for your various load cases, including the moving load. And there it is. So that concludes the demonstration for the steel girder wizard. I hope you found it to be useful and informative. As I demonstrated, the wizard is very easy to use and time-saving. So any engineer, regardless of whether or not they have experience with finite element modeling or not, you'll be able to use this wizard easily and learn it swiftly to create detailed steel girder bridge models. And in addition to that, if you do find that you need this to use right away, please do contact us with the information below, and have a great day.